So good afternoon or good evening or good morning. We are going to give one more minute that people is joining us. So if you can wait just 1 minute and then we will start. So I think we can start now. Very welcome everyone to our first panel discussion online. This is organized by IGS UK chapter and the IC Northwest. And this will be a panel discussion about geosynthetics for sustainable development. The host today will be myself, Patricia Guerra Escobar, as chair of the IGS UK chapter, Yuli Dulala-Rigby as chair of the ICE Northwest, and Kasia Samara as part of the IGS UK chapter and also member of the IGS Sustainability Committee. So before starting, just some housekeeping rules. The panel will be recorded. Please keep your camera on, and we want this to be a very interactive discussion, so don't worry, please put your camera on. Please keep yourself on mute during the initial discussion, so when someone is speaking. And each panelist will start with a short presentation, and after that, we will open the Q&A session for all to participate. Please raise your hand for any question, comment, or send your question on the chat, and we will call your name so you can read the question. The way we are going to do this, our 4 panelists today, I'm going to present them, and then a short, they will have a short presentation on the topics that you can see on the slide. So we have Natalie Tooze, IGS Vice President, and Natalie is going to talk about UN goals for sustainable development and geosynthetics. So Dr. Tooze has been conducting research on geosynthetics for the past 28 years, with particular emphasis on hydraulic and environmental applications. She is the head of the INRAE Center of French Public Research Institute, which has been at the forefront of geosynthetic research since 1972. She has authored about 200 papers and serves or has served on a number of national technical committees, especially for the use of geosynthetic clay liners and geomembranes. Her experience has been acknowledged in the field of standardization, and she has served as a convener of WG4 hydraulics, ISO TC 221 and CN TC 189. Dr. Natalie Tooze was a keynote lecturer at the EuroGeo4 and EuroGeo5 conferences. She was also an invited lecturer at the 7th International Conference on Environmental Geotechnics in 2014 in Australia, and was awarded the 6th Giroux Lecture that was presented along the 11th International Conference on Geosynthetics in Korea. Our second panelist will be John Krause, IGS Executive Director, and John is going to talk about the IGS Global Vision. Alongside the smooth running of IGS operations, John's focus is on communicating the benefits of geosynthetics for sustainable outcomes. He also provides senior executive service to organizations that promote sustainable practices. Previous roles include Head of Sustainable Urbanization and Director External Affairs at RICS, where he led international research and sustainability programs. and also the establishment of the award-winning World Built Environment Forum. Prior to joining IGS, John served as a UK diplomat, completing substantive postings to several European capitals with a focus on multilateral issues, including climate change. Our third panelist is Tim Chapman, director at Arup, and Tim is going to talk about the challenges to reach net zero, history of progress in the UK towards carbon reductions in civil engineering. Tim is an Arup director and highly experienced infrastructure designer who has worked on a range of large transport, energy, and property projects. He has been an influential agent for change in setting up the new systems to make UK infrastructure systems much lower carbon. He is very interested in devising ways to make our infrastructure system increase national happiness by promoting prosperity and well-being, as well as addressing climate change, biodiversity, social value, and resilience. Tim is a fellow of the Institution of Civil Engineers and of the Royal Academy of Engineering. He is currently chair of an ICE workstream for identifying system-level reduction in used carbon and a member of the Association of Consulting Engineers Net Zero Task Force, charged with preparing an influential industry statement for COP26. And our fourth panelist is David Shercliffe. He is chief engineer at ABG and also part of the IGS UK committee. David is going to talk about case studies, practical and quantifiable solutions with geosynthetics. David is a civil engineer who has worked in the geosynthetics industry over the last 38 years. He has helped develop several unique materials and given many presentations around the world at conferences and seminars to educate engineers in efficient and most importantly, environmentally friendly solutions which save, in some cases, vast amounts of CO2. David serves IGS UK by representing them on the BSI Committee for Geosynthetic Standards and European International Standards as an expert in hydraulics applications. He also serves in the IGS International Sustainability Committee, which looks for ways to communicate the very large sustainable benefits of using geosynthetics in ground engineering. Recently, David has been invited to represent the IGS in the ICE Community Advisory Board to further encourage best practice for ICE members to obtain net zero carbon impact in civil engineering. So now with all the presentation, I pass over to Natalie, who's going to start with her short presentation.
Thank you very much, Patricia, for this introduction. And I will thus share my screen. And I would also like to thank the IGS UK chapter and the ICE Northwest for inviting me to participate in this webinar. So before addressing geosynthetics and the Sustainable Development Goals, I would just like to remind you, maybe inform some people who are not familiar with those products about what geosynthetics are. So geosynthetics are products defined by an international standards in which at least one of the components is made from a synthetic or natural polymer, and that is presented in the form of a sheet, a strip, or a three-dimensional structure used in contact with soil and or other materials in geotechnical and civil engineering applications. As regards now the Sustainable Development Goals, the 17 Sustainable Development Goals of the United Nations have become now one of the terms of reference when we deal with sustainability questions. Geosynthetics contribute to the 17 Sustainable Development Goals that are presented on this slide in many ways. And this translates into communication vectors, among which the series of Did You Know, which is published by the IGS and available on the sustainability webpage of the IGS. This allows to disclose the many ways in which geosynthetics and the IGS contribute to sustainability. When we refer to the 2 pages document that give more details on how geosynthetics make significant contribution to the UN Sustainable Development Goals, we see that what is detailed there is that surface and groundwater is preserved and safeguarded from contamination thanks to the use of geosynthetics. Environmental protection and resilience is achievable. Unequal solutions are possible, and economic growth and welfare is enabled. I will give a little bit more details on those 4 aspects and leave to David and team afterwards the question of energy consumption and reduction or replacement. So when we take a look at where geosynthetics are used, they are used in order to prevent natural disasters. They're also used to connect people and to help people living together, thus contributing to the UN Sustainable Development Goals. They also are used in order to promote economic development, and I will deal a bit more in detail on that in the following. They serve in order to protect our environment, especially in landfills or in mining applications, and also in agriculture, for example, in aquaculture here, in order to contribute to feeding the world, which is also part of the UN Sustainable Development Goals. And finally, they contribute to promoting quality water for all by promoting the transportation and storage of water. Why can we say that unequal solutions are possible? Because geosynthetics are manufactured materials, and for that reason, they work in many ways, many applications better than geotechnical materials that they replace, like, for example, concrete. And their performance is gained by the fact that we use manufactured materials with properties that are known. And for this instance, standards have been developed in CEN, in ISO, and in ASTM, for example, in order to guarantee the reduction in the variability of the features and properties of geosynthetics. Why can we say that economic growth and welfare is also enabled thanks to the use of geosynthetics? There is a common misconception that sustainable solutions for infrastructure will cost more. But in fact, when we take a look at geosynthetics and their use, we can evidence that geosynthetic solutions were developed to provide first financial benefits. That was the origin. And this is provided by easier and or accelerated construction, immediate usability, and long-term savings in relation with extended life by increasing the volume, for example. And this has been presented in a second Did You Know of the IGS. And other aspects that are related with energy savings and environmental benefits then became obvious, and especially in terms of the reduction in emissions. And in addition to that, there are also some aspects for which it's difficult to distinguish between financial benefits and environmental benefits that are related with the reduction in energy consumption, in the quantity or need for select soil material, and in the lower requirement for maintenance in relation with the lifespan of those materials. And why is welfare enabled then? Because as we see that geosynthetics bring financial benefits in relation with the number of avoided costs, more money is available. And when more money is available, we can say that in a simplistic virtuous circle, as financial benefits are made, this money can be invested, and it can be invested in infrastructure, in healthcare, and in education. It is important to notice at this stage that the IGS also contributes to education through the resources that are made available from the IGS, like the digital library and the Educate the Educators program. This investment in infrastructure, healthcare, and education results in getting better educated and efficient people. And in a virtuous circle, this finally results also in avoided cost and financial benefits. When people are confident that their children will live in good conditions, be educated to prepare their future and live longer, the birth rate decreases. And we expect a decrease in birth rates by the year 2064. And then people are becoming more concerned by the quality of their environment and the decrease of population. We can expect that. And the awareness of environmental issues should result at some point in a positive impact on climate change and use of resources, thus also contributing to welfare and economic growth. So these are the elements that I wanted to show today in the relation between geosynthetics and the Sustainable Development Goals. And I thank you for your attention, and I will now leave the floor to John.
Thank you, Natalie. I'm sharing my screen now. Hopefully that's going to be visible to everyone.
It is.
Excellent, thank you. So, I mean, Natalie has given a very clear, I think, description of how geosynthetics have a role, a very important role with the Sustainable Development Goals. And the next speakers are going to talk about some of the very practical things that we do. I want to kind of just try and bridge that a little bit by just talking briefly about what the IGS has set out as its sustainability position, its statement. And before we did that, we thought it would be a good idea to ask our members in the industry where they were on sustainability, and in particular, how do we understand the supply chain? Because I think it's very clear, everybody on this call will be very aware of the outcomes that geosynthetics deliver, such as reduced carbon savings use, or the environmental and societal benefits and improved quality of life. But what about the supply chain? How sustainable is that? So we ran a survey of our members last year. It's the first time we've ever done it. And of course, as such, it's just an initial snapshot, and we'd expect a better picture to emerge over time. But let me just give you one headline finding from this. The important aspect that we looked at was intention and transparency. So if you look at what investors and regulators are saying and requiring now, if you look at what pressure groups are demanding, communities and employees as well, they're increasingly expecting companies to have an environmental statement, and for companies to set out the policies and targets that demonstrate a genuine commitment to responsible business. Now, over half of our survey respondents said that they already have an environmental statement or that they plan to have one. That's averaged across all of the different groups of product manufacturers, engineering design services and production, product design, distribution and sales companies. Manufacturers were particularly high in this response, so 43% of them said they already had an environmental statement, and 26% said they plan to have one. But on average across all of the sector, it was a little over half have a statement or plan to have one. Now, contrast that, however, with whether they are sharing that statement online and indeed going further than that and publishing their performance online. And very few, less than 10%, are publishing the environmental statement online. So there's a big opportunity, if you like, for actors in the industry to start to make that commitment public and that performance public, and increasingly build confidence amongst the stakeholders that will matter to them. Now, if the IGS is asking our corporate members to be transparent, then we need to do the same. So we've established our own statement. It was published in December of last year. It begins with a very clear assertion about the positive contribution of geosynthetics. It then makes a commitment, sets out our commitment as an organization, so meeting our legal requirements, minimizing our own footprint, and working to maximize the benefits of geosynthetics. And finally, a statement that we're committed to communicating our approach on sustainable practices and engaging with everyone we need to engage with on this. There's more detail, of course, in the statement. The link is on the screen, and that can be found from our sustainability page on the website. Well, what does this mean in practice? So firstly, very briefly, our operations. We're requiring our service providers to supply sustainable office space. We're asking our journals, publishers, to follow sustainable practices wherever possible. We're going to continue to hold our events online because there's a clear environmental benefit to doing that, where it makes sense to be online. And where we're going to have in-person events, we want to try and maintain sustainability standards there. So, for example, we've just selected the host city for the 13th International Conference on Geosynthetics. It's going to be Montreal. And as part of that process, we insisted that all of the bidders had to demonstrate high sustainability credentials. And the winning bid, in fact, is going to be held in a net zero conference center. As for our members, we're encouraging everyone who's a member of IGS to understand and foster and promote concepts of sustainable development. And we want to contribute to that as much as we can. Natalie mentioned, for instance, the Did You Know series. We also have a sustainability ebook. We're publishing and making available research papers and case histories of good practice. And we need to hear from you on what is actually useful in supporting you to be more sustainable in your everyday work. And in terms of influence, we have a number of members who are representatives on the various important bodies, such as the coordinating committees of our sister organizations. We've just been going through a very intensive period of work with the European Association of Geosynthetic Product Manufacturers, the EAGM, and also the Geosynthetics Materials Association of North America, to help coordinate with them how we should respond to the European Commission's current consultation on microplastics. And microplastics is a significant risk for us in future. So that's something we need to give more attention to. And I'm very happy to talk about that in the Q&A after these presentations. So that's a very quick overview of the IGS's commitment to sustainable practice. And I'm going to hand over now to Tim.
Thanks, John. Just getting this to work. It's my turn to check. Hopefully you can see that.
Yes.
Excellent, good. Thank you everybody for the invitation to come here. Both IGS and ICE, really chuffed to come along and talk to you all today. I was just going to quickly go through some of the things about big infrastructure and geosynthetics as I see it. It's really interesting. I think we're as a sort of a pivot point generally. I'm going to do something very pretentious. I'm going to quote Lenin. I've never done that before. Lenin apparently said there are decades when nothing happens and weeks when decades happen. And I'm sort of reminded of that at the moment, that we're coping with a huge range of changes. There was technology changing, sort of industry 4.0. We have carbon diversity crises. We then had COVID, which changed the whole future of work, the future of transport, the future of demand in many ways. And now we have the Russia-Ukraine war. So we're facing actually unparalleled times. I mean, makes most of our lives, I think, seem fairly tame and fairly quiet with the things we're facing at the moment. And in this, there's actually a time of huge opportunity, a time to try and actually change how the world works, and actually an obligation to do so. So just very quickly going through some of these things. Speaking as a designer for infrastructure and cities, it used to be we would work out, is it stable? Does it work? Build it safely, and ideally build it on time and to budget, although that didn't happen as often as it should have done. And one of the rare examples when it did was for the Channel Tunnel Rail Link. And I've got a picture of Tony Blair at the opening of the CTRL, now High Speed 1 in 2003, saying the Prime Ministers very seldom stand in front of big schemes to be on time and on budget. But the actual challenge to us now is much broader, is to actually make sure that projects we do are resilient, are they low carbon, and actually whole life low carbon, not just actually in terms of the capital carbon that goes into them. And what are the broader benefits? What's the impact on nature and biodiversity? And actually, how do they benefit society and individual members of society and overall achieve social value? And then we have the challenge of actually jobs and leveling up. But then we circle right back down again, because I was at a talk with the IPA about a week ago, and they said we have run out of money. The country is £500 billion poorer than it was 2 years ago, and therefore we're actually more for less. And how can we actually achieve better value in the schemes that we do? So we're now challenged to achieve a huge amount more than we ever were in what we achieve on projects. And we talk about net zero, but actually net zero can be a very hackneyed term. Sometimes it's actually very good and very ethically meant. Sometimes it's actually not. It's more of a marketing gimmick. Globally, we know what net zero means. We have to try and reduce the sort of the 40 or 50 billion tons of CO2, the net flux up into the atmosphere, down to zero. Naturally, before the Industrial Revolution, it was negative. It was CO2 was being net absorbed by the planet, but we've actually messed that up really badly. On a national level, it's also clear what it means. We know the territorial consumptions and we know the sort of consumption-based emissions. However, when you come down to cities and companies, it's less clear. And this is the area where people quite often, marketing can maybe triumph over physics in terms of what is actually net zero or not. I'm just going to touch very quickly on PAS 2080. A standard was published in 2016. I was involved in conceiving it and writing it as part of an ICE initiative at the time, along with government. And the critical thing from all of us, I think, as engineers, is to learn the units of carbon. So low carbon talks about the capital carbon to build something, operational carbon to run it, and then the use carbon. And for a transport project or a transport area, like for instance, Heathrow Airport, we have the new T5, which was fairly high carbon. Running the airport is fairly high carbon, but the use carbon is vast. All the planes that take off and land from all over the world in terms of their emissions. But this sort of is a good way of looking at things, and it gets around some of the problems of scope 1, scope 2, and scope 3, where it can become very confused. Yannick Giesekam is an excellent academic in Strathclyde University, and he did this graph as part of an ICE lecture that he and I gave a couple of years ago of looking at the UK's territorial emissions falling from about 800 million tonnes in 1990 to about 450, so a really, really good reduction. However, our consumption-based emissions went from 900 to about 800 over the same period, not nearly so good. And people forget about the fact that we import an awful lot of our carbon. But when you come down to what we do as infrastructure providers, surface transport, the operational and user emissions of that have not budged at all in the sort of 30 years between 1990 and 2020. But capital carbon has actually increased. We now actually put more carbon into the projects that we do. And going through the big infrastructure sectors, and I'm not going to labor this graph, these again is in million tons. We can see energy is one of the really big providers, consuming about half of our territorial emissions, and transport is another huge number. And we can see where these are in terms of operational and use carbon. I only show these figures to help us actually understand where we are with some of the schemes. I said before, we need to actually understand about the scale of what we achieve. And I actually think the A14 extension in Cambridgeshire, a project with quite a lot of geosynthetics in it, going over very soft ground, is a really good case. It's about 1 million tons of CO2. We come down at sort of, I helped design the M4 around Newport scheme in South Wales. It would have been about 500,000 tons. The M54 M6 link road up near Ely is about 100,000 tons. Going bigger, we have Lower Thames Crossing, 2 million tons. Heathrow third runway is going to be meant to be about 3.5. And in practice, it would have been maybe almost double that at the end. And then HS2, about 13 megatons for, this is the full HS2 before it got scaled back. But going back to the A14 of 1 megaton, the scale to sequestrate all of that carbon, we need a forest about 30 kilometers by 30 kilometers square, or about the size of London. So it sort of shows that nature-based solutions can be a solution to put some of the issues, but aren't the whole thing. The critical thing is we need to learn to build far more efficiently. And people at the IC have been really good. And the traditional materials of what, as example, a cubic meter of concrete is in terms of its carbon. They reckon it's about 430 kilograms, about half a ton of carbon, mainly the cement, quite a lot in the steel, quite a lot in the construction, not that much in the transport, and then goes through the other various aspects of the component. And I think it's really good when we get down to this level of granular detail, because we can then see how we can save carbon. We can see here that if we didn't reinforce the concrete, we'd get rid of 20% of it, but actually the steel makes it an awful lot better. And the same thing actually applies, I think, when we think about geosynthetic reinforcement of soil. And soil earthworks are actually usually very low carbon. So anything that actually makes more earthwork solutions more practical are very, very good. The critical thing here is that we don't compromise the whole life carbon. And what I've seen happen occasionally is people try and reduce the capital carbon, but at a cost of the whole life carbon. So working on East-West Rail, I have seen people suggesting, can we make the station slightly smaller, slightly poorer? But that would be a really bad thing to do, because the critical thing about East-West Rail is mode shift. It's getting people out of their cars and into public transport. And all the things that engenders, it means that we have better places because we can have more shops next to stations. It means that people travel around in a way that engenders better community cohesion. It means that people will actually be healthier because they'll generally walk or cycle to the station, and not just get in the car from point to point of where the whole journey is. So when we look at actually all of these crises together, we can see we can solve an awful lot of them by advocating public transport. But in that, we need to actually be very aware of the whole life carbon, not just try and reduce capital carbon. The UK is in a really interesting position at the moment. The Green Book is going in the right direction. It's still not there yet about how we choose to invest. The construction playbook was published just over a year ago, and it's really encouraging. Rather than buying cheaply, it encourages government departments to actually buy for better value and better whole life value and broader value. And actually, it's comply or explain status. So therefore, if somebody now buys cheaply in central government or from one of the bits of central government, they can be chastised for buying badly. And the other bit, which I really like, and I'm going to touch on very quickly, is the Construction Innovation Hub Value Toolkit. It talks about all the various values and tries to deal with them coherently, so that when government buy, they buy them much more logically. And the bit that I really like about the value toolkit is that it reinvents the sort of the standard stages that we talk about when we look at how we evaluate projects. And yes, it's a design stage, a bit like REBA or GRIP design stages, but fundamentally it goes back to the source and tries to work out how we can get the need better. So critically, we don't spend enough time on projects. Often we end up design the projects that we're given and don't have enough time to challenge them and make sure they are going to achieve the right things for society. However, if we know the mission and the outcomes a client wants to achieve, we can then actually try and reevaluate the projects and come up with better projects. Too often, I think in design, we can do the wrong thing well. Misquoting Keith Waller of the Construction Innovation Hub as our industry. The critical thing is we need to choose to do the right thing for long-term societal benefits earlier, and therefore we need to come earlier in the process to make sure we choose the right projects to do. And the impact of our carbon decisions can be much higher if we actually evaluate them at this stage, including the option of doing nothing sometimes. So I think in terms of this, there's three crises we need to solve. There's a crisis of carbon, there's a crisis of biodiversity, and actually there's a crisis of social value. And we need to do all of these things together. We don't have time to do them individually. So we need to come up with integrated solutions that are better for everybody. We need to spend more time building more of the right things and stop doing more of the wrong things. Mode shift in all its various forms is a critical issue here in terms of big infrastructure. So from a transport point of view, we need to get people to actually use more virtuous forms of transport. Same thing applies to our electricity grid. We need to actually have more low carbon power stations to mean we could turn off gas and coal and have a much lower carbon grid. And actually fundamentally, coming back to geosynthetics, I'd actually challenge, do we know the true capital carbon for geosynthetic solutions versus the non-geosynthetic ones? We all know that potentially plastic materials can be bad. However, I think in this case, many cases, they will actually be really good. I know David's going to touch on this in much more detail later. And as I said earlier, we know earthworks tend to be very, very carbon efficient. And we know geosynthetics allow much more efficient earthwork solutions to be used. So I would expect, my prejudice is that geosynthetics generally will be proven to be very, very good solutions. We also then need the research that John alluded to before to look into geosynthetics and actually make them even more carbon efficient, especially get rid of the sort of microplastic and other issues and find ways to make sure that they don't end up damaging nature. So as an infrastructure designer, I come to you guys and I challenge you to come back and prove how carbon efficient your solutions are compared to the non-geosynthetic ones. And I expect to get some very good news. Thank you very much. I'm handing over to David, who's hopefully getting his PowerPoint together as we speak.
Hello, everyone. Thank you again for the IGS inviting me to speak. On behalf of those that, if you like, the geosynthetic face, I work for a manufacturer and have done for a number of years, as Patricia indicated. Have I shared my screen successfully? Can I have a thumbs up?
Yeah. David, go into the presentation mode, though.
Yes, okay, thank you.
Yep.
Okay, great, thank you. So I'm going to be looking at some practical examples, and Tim gave me a nice little challenge there. So I don't know whether I'll completely amaze him, but I'll try. So what I'm going to try and cover is just really, what are we trying to save? Tim mentioned about groundworks being very efficient. I want to look at some of the other materials used in groundworks. I'm going to look at a method which has been around for some time, but developed a little bit. I think it's called the RAP method. I'm glad Tim emphasized the A14 because it's a great exemplar where geosynthetics were used extensively. Just got one example as a model of how it worked with the contractor, the joint venture. I've got some other examples, and hopefully we can move on to discussion questions at the end. As Tim suggested, the calculation methods I'm going to be putting forward are from cradle to construction, and at the moment I haven't considered to the grave, but I think the major embodied carbon is in the building of the material. So the saving of the precious materials that I mentioned, it's not so much moving the soil around the place on the site, it's what's imported in the materials that I'm, if you like, targeting and trying to minimize. A quarried stone, dredged or dragged excavated river gravels, sands, quarried clay, concrete and asphalt. And geosynthetics have got solutions which can reduce, in some instances drastically, the amount of these imported materials. Moving on to the RAP method. The RAP method was proposed by the Waste and Resources Action Programme. That was in 2010, and it was looking at geosynthetics in its ability to save these materials and also to use unsuitable fills as well, as opposed to imported mineral materials. As I say, it's cradle to construction method, and it tends to focus from a site-based method. In other words, it's looking at what's going on site, and then we bring things in to site and see what impact that has on the site. It's split into 4 parts, and this is how the first part, just labeled A, is the removal of waste. This can be a difficult thing to calculate unless you have very good cooperation from the contractor who gives you all the figures. But what we're talking about here is a simple example, just to the right of the picture there, is if you had no geosynthetic, maybe the calculations show that you needed 480 millimeters of granular material. With a high quality geogrid, you can reduce that by half. And therefore, if your finished level is the top of the diagram, to achieve the first non-geosynthetic solution, you will have had to excavate out, if you were in cut, for that 225 millimeters of waste, in quotes, material. That would have to be moved to somewhere else, and that is quite a considerable amount of earth to move in a cut situation. And that has to be assessed on each one. B is the imported materials, cradle to gate, so anything that's brought onto site. The C is the transport element of getting those materials there, and D is the construction element. So in a little bit more detail, I've mentioned A already, the cradle to gate, and calculating the embedded carbon values that are in those imported materials. So if we look at minerals, you're looking at road and drainage aggregates, clay, concrete, and they're translated into a per ton value or per square meter value. And where those figures come from, there are some very good indexes available. DEFRA publish transport costs and capacities. The industry itself publishes embedded carbon figures. Bath University has produced a whole series of values for all types of materials, including stones, concretes, etc. So they're readily available for the industry to use. There's also some indications of waste levels and breakages that you'd expect with any, say, structural materials. For geosynthetics, as Tim or as John mentioned, factories are doing assessments on their carbon output. I know a number of ours and my colleagues in the factories around the UK have undertaken to do this. And this is where you get an independent body verifying the output of your factory. So you look at the electricity consumption, natural gas through heating, LPGs and forklifts, water for cooling, and down to even the office power and the canteen facilities, which is all measurable and verifiable. Then you can translate, obviously you get your raw materials in, which may be the polymer, if it depends on your manufacturing process. And these can be calculated either by industry published information or from the factories themselves. Also external bought in products. If you're putting two products together, the individual factories can tell you what they are and the transport from their factory to your factory. Also under ISO 14001, looking at environmental savings, there's waste and recycling, which can be optimized and calculated. And that can then, once you know how much it costs to make your, to run your factory, you can translate that to your actual products and look at the embedded carbon in the individual products and also in composite manufacture. So you may have a process for sticking two products together. And so you end up with a long chart, as I've indicated there. Part C is simply the road transport, the different types of vehicles that you take the product to site. And obviously the type of vehicle has different outputs, which again is readily available. When I'm assuming a quarry, I do a default assumption that the quarry is only 10 kilometers, 10 miles, I beg your pardon, from the site to the actual site, the quarry to the site. So which is quite conservative and generous, I think. The construction methods, of course, is offloading to the compound, temporary works. I won't go through them all, but you know the sort of activities that go on site, including welfare overheads on site. The rate of installation, of course, is a key element, and the machines involved in that. Now to the A14, again, Tim's introduced it well. It had various sections and it saved a large amount of carbon. A large project, as Tim described. I was very impressed that they didn't actually appointed environment and sustainability director specifically for the site, which shows a certain attitude to the determination to cut carbon. Highways Agency had an environmental impact statement, and they on the site, they had borrow pits, etc., to make minimum transport. They had concrete factory on the site, etc. But one of the main challenges was to re-engineer the actual specification to save carbon. And the JV gave itself a 20% reduction target over and above the contract specification. The specific example, just as an exemplar, there were many ways they did it, was to look at buried structures and the drainage of buried structures. And the specification was for concrete blocks put behind all those structures in all sorts of places. So you're typically talking about a sintered block, 225 millimeters wide, with a capping stone, and it was filled with stone to take the drainage on the back of a buried structure. The alternative was put forward by one of the engineers on the site, And this is a geosynthetic composite, which allows a similar or greater amount of flow. So functionally, it's equal or better. Again, that section on A is a possibility of considering because you save that amount of space. It rather depends on what your backfill is. I've got to show you the picture which says if you had some blocks and some infill stone, the capacity on road transport would be equivalent to 60 of these to one of the drainage geocomposite of being delivered from site. In terms of the installation part, the construction part, the actual placing of the blocks, etc., the speed is related to environment. So if you get off the site quicker, you expose people for less time, you cause less disruption. So one 550 blocks is equal to one roll of geosynthetic. Now it's 55 square meters. And carrying out the calculations for parts A, B, C, and D for this particular application, and this was just per 55 square meter roll, building up. In this instance, I didn't take account of the contribution to the saving, possibly because it was an unknown. But in terms of the embedded carbon, which came from those calculations I described, there's, as you can see the figures, I won't read them out. We did an actual exercise to look at the other part of the specification, which was for no fines concrete. The important number at the end is that comparing the two, which I believe is a fair comparison and maybe very conservative, as I suggested, is a 94% saving on carbon using a geosynthetic composite solution. What was even more satisfying is that because the site was incentivized, or the staff were incentivized to come up with carbon saving solutions. And there's a young man, Stuart Wilson, who put forward this as their own case study and put forward how they saw it. The first thing they looked for, of course, that it was cheaper. Well, I'm pleased to say it was 80% cheaper, 94% carbon saving, 55% faster to build, and it was safer to build because you haven't got stones hanging over you, and there was less waste, no breakages. I've showed you this diagram before, but you can again see a similar message using a geogrid to save, and you can see the 55% saving on carbon and a considerable saving in cost. This is from the RAP report. This is an example of a reinforced soil wall with the front facing, and the comparisons again from cost was 55%, but again, 57% saving on carbon. Another example is where another buried structure where you're using gravel instead of a block system for large areas of gravel. And this could apply to any area where you've got large sheets of imported aggregate. This is an example. It was only 150 mil deep, and the replacement saved 34%. Again, an illustration of the sort of size of a roll of material can be equivalent to. Another application, landfill basal liner, a 55% saving over a drainage gravel and a compacted clay liner versus a GCL and drainage geocomposite. That's geosynthetic clay liner. A large project, I think in South America, showing a very light geomembrane liner as opposed to a clay liner. The saving again was 72% saving using a geosynthetic. I haven't got a calculation for this one, but I put it in deliberately. But when you're trying to build a rock armor defense underwater, permanently underwater, and then put a theoretical filter in using graded stone is a very expensive and very difficult thing to achieve. Very easy to achieve with a geosynthetic. Now, questions hopefully I've got to try, and one of the frustrations I got, we've known some about this for over 30 years, I believe. RAP did their report in 2010, and there are various ways to get the message over. Tim talked about trees, etc., and maybe individual methods. And if we're talking to our clients, and I believe it's the ultimate clients we have to talk to, so rather giving them lots and lots of numbers, talking to them in visual effects, maybe on a personal scale or a city scale, or even an earth scale, or even being as gratuitous as showing them what does 4.2 million tons of aggregate look like. And I think my video isn't working, but not to worry. And that whole area is exploding. And that's, if you're going to quarry that amount of material, how is it hauled? And I suggest that it's a little more than 10 miles. There we go. Maybe I should do the carbon calculation on that one as well. And then we can use carbon equivalency or offset. The equivalency being how many trips there are by a plane from where to where, or how many ash trees. DEFRA seem to like these, but I'd be interested to know if there was any other more effective methods that others have got. Some of the problems with mineral-based is, as I've emphasised, this is a calculation I've done on 1,000 square metres of a landfill-based solution. And the thing that seems to stand out most of all is, at the moment, is this transporting materials and the damage it does to the site. But there's large amounts of excavation, and the manufacturing subquarter is a small part, construction and save, and that was a 64% saving. And problems with geosynthetics, I found talking to customers with similar numbers that the numbers are so big that people find it is it credible as a sort of reaction. And another thing that I think our own industry is hung up on is that there are just too much discussion about the problems of plastic and not the great benefits. And I think, as Tim again mentioned, we haven't got time to worry about things on that sort of scale when we're not worrying about the large savings. Construction takes up 26% of global carbon impact. And I wonder if government has got a hierarchy and the construction industry of the need to solve these problems. There seems to be a lot of emphasis on steel structures and concrete and not so much on the groundworks. So, and I'd also be interested to know what the hierarchy of of other savings in the environment that Natalie mentioned. You know, how do we measure the effect of the saving to do with flooding, contamination, safety time, saving, and traffic disruption? I'd like to know how those are measured. So I'll just then end there and hopefully open the floor for discussion. Over to you, Patricia.
Okay, thank you very much to all our panelists. So now is the time for you to ask questions and comments about what you have seen previously. So I don't know if someone would like to start, and then just, as I said, please raise the hand and then we will go through with each one. Yes, Peter, if you mute yourself, please. Yeah.
Hi, Patricia, thank you. Yes, I'm happy to start. And I think the key thing about those presentations, they all tied things together with one element that most of my clients are always very keen on, that is money, cash. Now, I've been in this game a long time. I've been qualified a long time, but every single contract that I've worked on over 40 years has been driven by money. And I think as engineers, we've always been very nervous about that. Yet now it seems with this sustainability drive, carbon essentially costs money. But when I started to look at this some years ago, it seemed to me that the benefits obtained by saving carbon were also hand in hand with saving money. And David's examples at the end all talked about that. I wonder if we as an industry we're making the joins together, but we are trying to talk about carbon in tons, so on and so forth. But the fact of the matter is that every single time we do this, we are actually saving both money and carbon. And those overall benefits should be a win-win, as I think was on one of David's slides. And indeed, Natalie started off with in her presentation, because essentially people are always concerned that these things are going to cost more. And in fact, they can demonstrate that sustainability actually saves us money. The key issue then we're left with is that plastics being good and bad. And I know we've heard a lot about that. And I think in actual fact that John said he was going to talk about that later in the discussion. I'd be interested to see how we can all get together as an industry to say that all plastics are not bad. But I think the saving of carbon and the saving of money tied together should mean that we are pushing an open door with all of this. And I'm not certain that we've yet cracked that nut, but I think we could all of us push harder in that direction. I don't know what the panel think about that as an option.
I'm happy to come in as a first response, Peter. So thank you for the comment. Anglian Water did some really good data about 6 or 7 years ago where they proved the same as David did, that there's a very high correlation on projects between saving money and saving cash, because basically carbon is proxy for either material use or energy use, both of which we know are very expensive. It's not complete, but you're right. I also do see now quite a lot of big public sector clients especially are valuing carbon in its own right and are actually offering very, very big incentives to save carbon. So I would sort of distinguish between value for money and value for carbon. And I think actually what we need to do as society is come up with solutions that are actually better on both. Sometimes we might end up spending a bit more money if the client is minded to save carbon. I'm just basically, I agree with you largely, but it's not always the case 100% of the time. And I think carbon needs to be saved. But ever since Heathrow lost the third runway, I should say, in February 2020, I think the dial has turned. I see HS2 have actually pushing it really hard. National Highways are pushing it very hard. So an awful lot of the really big geosynthetic users are now want value for carbon as well as value for money. And we need to do both.
May I come back, Patricia, that one of the reasons I asked that question was exactly that, Tim. I mean, I know from my own experience that clients are terribly keen to demonstrate their green credentials by demonstrating saved carbon and almost embarrassed at the money savings. And as consultants, we struggle with that because we then have our contractor client ultimately looking to deliver projects on time and in budget, and we're pushing that money side. And I accept that's why it happened. And I think the problem is that we're doing the same job twice if we're not careful. And that's why I kind of put that one out there, because I think there's a direct correlation. We know there's been work done that says there is a direct correlation, but the embarrassment about saving money, and as you rightly said, the construction playbook is now talking about value, not cost saving. And yet we're talking about sustainability, which will affect the same. Do we take that thing on at the pass, or do we continue to talk the two things separately? I really don't know.
I was trying to think. I think project. Sorry, we're, as I said in my talk, we're at a crossroads. I think in the industry, and we need to actually try and achieve lots of things in our projects. If I had more than 10 minutes, I would have actually gone through. I think we need to actually solve the biodiversity crisis, and then quite often the projects we're actually choosing to do tend to be the wrong ones. In the Anglian Water example, they discovered that when they asked the project team to save money, they saved a bit of money, because actually being asked to value engineer something yet again isn't very inspiring. When they asked the project team to save carbon, they got actually very different solutions that tend to save more money than when they were asked to save money. So it's really interesting that by asking the team to do something much more inspiring and giving them permission to go back and actually re-engineer what they're doing. As an example, you're doing a sewage treatment works. If you go along and just skim 50 mil of concrete on all the various bits, you can probably still get it to work. But quite often they came up with very, very different solutions. They went back and found when they're asked to save carbon, they re-engineered the entire process. They re-engineered how they did things. They needed things that were actually very different sizes and often smaller. They did things that were really brilliant from an earthworks point of view. They invented the concept of the circular bucket, which meant that you didn't have the bedding around pipes that you actually have and other things. So I think it actually freed the engineers, the consultants, the designers to come up with much better solutions. Not just let's do one like we did last time, but a bit smaller.
Thank you, Tim. And I think you've introduced the other thing at the beginning of that, and then I'll shut up and let someone else have a word. And that is biodiversity and brownfield first development, which is again something which I think we need to involve in this whole process, because that's another strand of government planning policy with other environmental benefits or socioeconomic benefits, which may also bring environmental and ultimately carbon benefits. It's tying that glorious circle together, which again, Natalie talked about briefly in her presentation, and obviously has done considerable presentations in greater depth in the past, tying those things together. That's enough. I think it's time someone else had a word. Thank you.
Thank you, Peter. David, you wanted to say something?
Yeah, just to add on the A14, just to underline how pleased I was that there was a sustainability director, which costs money, of course, and their incentivization scheme on site, where engineers were awarded prizes and honored for finding environmental solutions, not just cost-saving solutions. The emphasis was on saving carbon, and that's a contractor doing that. So that's really good.
Yeah, and Patricia, if I can add to that, and I think it connects to a comment from Mike Calloward he did earlier on in the discussion, that he's saying that his company's got an EPD, so that's environmental product declaration. So people, I think manufacturers, and from what John says, the manufacturers are 43% already doing environmental declaration, whatever you said, John, I can't remember the exact words, but the industry is definitely coming around, and we are becoming stronger in the message. And there's a lot of manufacturers that they do go the extra mile to get the EPD certificates rather than just relying in the BAF report of generic values. But totally agree, we have to connect the two. So we can't keep on separating cost and carbon. They're hand in hand. And as every other speaker said, the one kind of complements the other, and they both work together. And the other thing that also works to our benefit now for geosynthetics is the cost of cement and the carbon of cement for lime or cement stabilization, which has been the traditional method and the one that makes sense when you've got massive areas to stabilize. This is now comes into question because of the high CO2 emission values. So we're in a good place. We just have to keep the inertia, and we just keep the momentum and just keep on going, I think, and just definitely keep the two together.
Yes, thank you, Yuli. And we have a comment on the chat, but I don't know sorry, I don't know how to pronounce the name. Yakakrishnan Putiya, he wants to come and mention your comment, or I can read it and then we can discuss. What do you prefer?
Well, I can read it out.
Yes, please. Thank you.
Thank you for the presentations. My comment is this: we all know that sustainable design requires assessment of impact on economy, society, and environment. Carbon emission is just one indicator under the environment category. The presentations today showed a lot of cases where carbon emission reduction is quantified, but what about the other indicators and how the reduction is achieved for the social and economic part? Because the theme of the event is sustainability for geosynthetics. So it would have been great to see some projects where quantification of the aspects other than carbon emission has also been shown.
Thanks, Jack. Go on, Yuli.
You're absolutely right. And I just want to say that some companies now, they're adding water, the reduction in water, because that's, of course, in the UK, we don't have a problem because we've got plenty of it. But in many parts of the world, water is a big thing. So you're absolutely right. Another big saving of geosynthetics is water, because we can also use recycle. So that's another added. So we shouldn't be in the infancy, but at least steps are being made, and people are looking not just cost or carbon, but other things that, other items that geosynthetics save. Sorry, Tim, go.
Thanks, Yuli. And just sorry to add to that, I mean, Jai Krishnan, there's a limit to what we can cover in a 40-minute presentation without solving everything. But I agree with your point entirely. And as an example, as Arup now, we check all the major infrastructure projects we go into to make sure that we agree with them. And I know that sounds in a way arrogant, but actually we also don't want to get tarred with the brush of doing something that's very bad. And as an example, there's still the Cumbria coal mine floating around that hasn't fully gone away. And I would be interested if actually anyone here, if you want to be provocative, is happy to work on a coal mine nowadays. I personally think it's probably unacceptable nowadays to work on them. I know they've made some cases about we need a particular type of coking coal. I also know that the other side say that you can do it perfectly well with smelters that work by electricity, which can come from renewable sources. But to assess every project, we look at them across 5 metrics. There's obviously value for money, as in we do not want to waste public money. There's value for carbon, equally important. There's resilience in all its forms. There's social value, as you said, and there's biodiversity. And when you actually track major infrastructure projects, I find against those 5 criteria, and I'm pushing very hard for the Green Book to actually get to this place, and I will not rest until the Green Book gets there. Then you can actually you can make much more interesting, I think much more intelligent long-term choice of the infrastructure we should build. To give you an example, Lincolnshire, the other side from IC Northwest, is a county that's almost bereft of transport links. The railways have largely been closed. There's no decent roads into it, and therefore the only thing anybody talented from Lincolnshire can do once they leave school is go somewhere else in the UK. I think one of the most fundamental basic definitions of sustainability is that people should have a chance to live where they were born and to grow up and get decent jobs where they were born. And therefore, I personally would support building a new dual carriageway into Lincolnshire. It's rubbish on carbon. It's probably not great in value for money, but actually I think we should spend our scarce money and our scarce carbon on levelling up and save them elsewhere, because the social value impact is actually so big and so important. We need to connect places into the rest of the economy. So I agree with your point. The point about today was, I think, to be much more focused on one particular aspect of sustainability. But geosynthetics work very well in most of them. Unfortunately, it's very difficult to show that a geosynthetic adds social value, although I know a lot of the companies that are represented here do a lot of engaging in the local communities. But definitely geosynthetics can add carbon value to projects very, very easily in terms of what they directly do. Likewise, they can add a bit on resilience. They can add possibly a little bit on biodiversity, but actually biodiversity has been broader and actually how the thing fits into the landscape and needs often to go outside the red line of projects. Once we limit ourselves to the red line, I think we often end up making quite bad decisions. But I agree totally with your question, but I think it would take us to be here for an awful lot longer than an hour and a half to address it properly.
Thank you, Tim.
All right, Tim, thank you.
Pietro has raised his hand. So Pietro, you want to come?
Yes, one additional aspect of the global problem is that David has shown that it is relatively easy to demonstrate the incremental advantage of geosynthetics. So the difference between the CO2 production of geosynthetic versus another solution with concrete, with something else. But a big problem, I think that with John Krause and others, we are discussing, particularly when dealing with microplastic, but in general with environmental emission of materials, is the total amount. The people around don't think to the difference for the specific project. They just think that geosynthetics is generating million tons of carbon, of CO2. So this should be another aspect that our industry should address, to show that also the global production of carbon, of water requirement, all the other indicators, also the total amount is limited. Not don't know if I explain myself properly. The total is more difficult to demonstrate than the differential. I don't know if you agree about this.
Yes, I think you are, in a way, it's more difficult with the numbers. It's easy to demonstrate specific values, as you mentioned, but yes, there is a lot of different areas that with the geosynthetics we can, or the solution using geosynthetics can also help from the, as you mentioned, from the economical and sociable applications on that case. And also there was one of the comments on the chat, just getting to that, that is not only to show the specific values for the products, but also what the solution itself, it can help. So for example, he's saying here that geosynthetics can reduce mudslides, landslides, and this can be also another benefit on that case. That was Wajahat Nassar who said that. So I don't know if you want to add to that, Wajahat? I'm not sure if he's still there, but David, you have another comment?
Yes, and it was one of the things I mentioned at the end of my presentation was that we've got to keep perspective, and this is my opinion, okay? We keep talking about other things that we'd like to measure, or, you know, if I come to you and say, would you like £1 million? And then I said, oh, well, I've changed my mind. It's 800,000. Would you then quibble and not take the 800,000 because I hadn't been specific on my number? And you didn't deserve it, and it came from nowhere. It's you know, talking about microplastics and talking about other benefits, which are great. Being specific and being real and credible with something that's often half the cost, safer, and is saving on average about 50% carbon, and we've recognized that carbon's important. Let's stop messing about. And I know in Japan, for instance, I understand, and Yuli will correct me if I'm wrong, but I understand the professor there is saying that the standard way that undergraduates are taught to build retaining walls is to use a geogrid. And that's the norm. Hello, welcome to civil engineering. Here is geosynthetics. This is how you do it. Oh, and there's this other funny stuff called concrete, which we tend to avoid. That's the flip I think should be happening.
Yeah, the additional reason in Japan, of course, is the earthquake superiority of geosynthetics because they're ductile. But yeah, absolutely. Beyond that, it should be the norm, and concrete should be the alternative. So we just have to. I was very surprised for the A14, David, that they conforming design was this blocks. I was not aware of these case studies. To me, you know, the drain that you showed, I thought it was a common knowledge, and it was I don't know, a household name in all sites. So that is absolutely mind-blowing that in the 21st century they still use the tradition. So there's a big disconnect somewhere there, and we have a lot of work to do, I think, because we know, and we must stop speaking to, what is it, preaching to the converted. That was a big eye-opener actually for the A14. In this day and age, I thought everybody used the fin drain because it just makes so much sense. So I think we have to lobby my idea is I think we have to lobby the ICE or whoever makes the contracts and put concrete right next an equivalent, carbon to cost, because they say there's a lot of talking but not enough doing. And at the end of the day, like Peter started this conversation of, it's all about money, but people have the misconception of money. So we have to work harder to make the message, you know, more known, and I don't know, go to universities, which we have done. We are starting to do, and, you know, little steps as IGS, but yeah, absolutely.
Thank you, Julie. I think, John, you wanted to mention something at some point, but I was not sure if you was giving the time to others. You are on mute. Yeah.
Yeah. No, there wasn't anything particular I want to mention. I have shared in the chat the link to our sustainability page where you can find all the Did You Knows. And they cover all of these issues, flooding, landslide protection, and so addressing all of the SDGs, which are, as somebody I think said, they're all equally important. Carbon is a vital one, but so too are all the other SDGs. And just in reference to the microplastics point, what we're saying to the European Commission, who are looking at microplastics, is this very clear message to them that not all plastics are bad, and geosynthetics are actually delivering massive SDG benefits across all the 17 SDGs. So we're saying to the Commission, you shouldn't be looking at us as a source of microplastics, which, by the way, we're not. What you should be looking at is all the massive benefits that geosynthetics are bringing. An example, lining landfill, and in landfill linings, we're protecting the groundwater from the leaching of toxic chemicals, much of it coming from plastics. So, we're able to say here are very clear examples of where geosynthetics are actually protecting the world from microplastics and chemicals from waste plastic.
Yes, thank you, John. I don't know if there is any more comments. I know that Peter has put a comment on the chat, and yes, I'm going to read it because I completely agree with that, is that because we have been working a lot on the area of geosynthetics, we are aware of most of the solutions and the applications, but not everybody, and this is a job that we have to do to go to universities, but also there is a lot of engineers outside that they haven't never worked with geosynthetics, or at least it's a word that they hear, but they don't feel comfortable with this. And this is part of our job, to make them understand and feel comfortable using these solutions, because always there is that, we still call our solutions innovations, but how much have been there outside? But there are still engineers that, or architects, or specifiers, or designers, or even contractors that they haven't used geosynthetic, or maybe they have used only one for one specific application, but they don't know that it could be used for different things, like you mentioned, in a landfill for as a barrier against contamination, or a reinforcement to be able to use site one materials. That is a big effect, not only on the CO2 reduction, but it has also a lot of implications on the economical and sociable aspects of that. So I think it's a work that we still need to do a lot on, educating and showing more of these things. And as you said, probably the sustainability side will be the better hook that you mentioned, Peter, than the cost savings in this case. Tim, you wanted to mention something? Sorry.
No, sorry, I just was clapping. I was agreeing.
Thank you, Peter.
Could I just make a final plug then, Patricia, with my other hat on as the chairman of ISO TC221, that currently we are very near to producing a suite of 10 design guides for designing with geosynthetics, which 6 of them are now published, the other 4 are nearing publication. Once those are available, we could conceivably, as the IGS start to push those out into the marketplace as methodologies for using geosynthetics in various types of design, and hopefully overcome that resistance over, as I say, 30 or 40 years of my career. And a lot of people on this call similarly have been trying to overcome for most of our careers.
Yes, thank you for that. So we have almost 10 minutes. I don't know if someone wants to ask or give some more comments about this.
I raised my hand following...
Oh, sorry, Pietro, I didn't see you.
Yes.
Sorry.
No, nothing. No, following the comment by Peter, we have done almost 6-7 years of work to produce this 10 document on design for geosynthetics. Now, I would like that the 11th document would be design for sustainability of geosynthetics, or design for carbon reduction, or design for, in any case, also a specific document on design for the sustainability part of the game. What do you think, Peter?
Possibly not through you, Chair, possibly not the forum, Pietro, but yes, but remember, sustainability when we started that process was nothing like as important in the world as it is now. And I think you're absolutely right. Potentially there is now room for design with geosynthetics offering environmental advantages and sustainability. You're absolutely right. Something for the review, perhaps.
Maybe even using those already guidelines that some examples or something, and also showing part of that sustainability side, also not to leave it only for the technical aspect, but also including a sustainable analysis or example on that, because that also will be very helpful. I just want to add a comment. There is something again on the chat that is talking about the recently time capsule project, and I am not sure, probably John can help us with this question, if IGS was trying. Oh, Julie can do it. But one thing I can say is that a lot of the technical committees, we have done already a specific time capsule on the specific application. As for example, the TC228 was talking about the reinforced soil structures, and we did a video showing the time capsule of that application.
Yeah, there was the submission of TC218, reinforced soil. So yes, we submitted the video, and I think it's there. There was quite a good, and time capsule of ISSMG is open and it's evolving. So I don't think the IGS has to do their own, but can add to it. And then it's all at the same place, which also connects. So yes, so geosynthetics are in the time capsule. What's that? If you look at it, yes, there is about the walls and structures, like Patricia said, and there's some other entries, but IGS can do something more extensive for the other applications. It's a good idea. But to keep it all in one place connects to the other comment in the chat from Ronmar, who says, I'm a graduate structural engineer, just wonder what's the name of the codes of practice. So also bridge the gap and the disconnect. So we all need to talk and discuss amongst each other. So a structural engineer should know, and vice versa. So I don't know, and is this the point, Tim, we mentioned the infrastructure engineer, that the IC is trying to connect all these different disciplines. So instead of working on silos, so the guy who specified those breeze blocks in A14 back again, obviously was not aware of geosynthetics, and he was obviously the bridge engineer, a structural engineer. But if there was this connection and we all talked to each other, then we wouldn't have had to waste the time to change the conforming design to an innovative design, like Patricia said, because it's not innovative. It's been around for so many years already. So that's another task for us, to bridge the gap and connect. So instead of working in silos, and yeah, talk to each other and know each other business. So Ronmar, yes, there is only one standard, and that's the BS 006. I can put in the chat, but I think it's deeper than that. Yeah, I don't know, Patricia, if you want to add on this one.
Yes, and there is a lot of guidance also that has been there. So of standards in the UK, as you mentioned, is the BS 806. But for example, there is a new temporary working forum guidance for piling mats, so working platforms, that also add the use of geosynthetics to, in this case, is to reduce the thicknesses, and also that will come with a benefit from the sustainability point of view. And there are some additional guidance outside. So yes, it could be, as you said, a very good opportunity for all of us to cover all the areas and everybody be aware of what is happening. And I think the work that Peter mentioned with the TCs, that could be a very good opportunity, because the design guidance, they can help a lot of the engineers in the different fields and in the different areas on that. Okay, is anyone else wants to come to the spotlight? There was a lot of, yes, like comments and in the presentations. One of the thing, this is recorded, so we will put this also available. So if someone wants to go through more detail to the presentations, that will be recorded. I also have a question, is if someone has an answer, and we were discussing reducing the gap, is how we as geosynthetic engineers or in geosynthetic industry, we can really get to all the, I know we have to educate the students and all of that, but how we close that gap and how we try to everybody to think about geosynthetics, if it comes not only from the cost point of view, but it has a huge benefits on the sustainability point of view. What else we could do, or what will you think it will be the ideas for us to do to make that happening much quicker than the years that have been at the back? Yes, Tim.
I think it's quite an interesting question. We've known that geosynthetics have been very successful at reducing costs for decades. Over my whole professional career, not quite as long as Peter, but very, very close, geosynthetics have often given very, very good economical solutions. They've often sometimes been a bit too complex. So if you're somebody who's not confident, there have been issues about how you specify them. But actually, if you're not competent, you shouldn't be designing in the first place. I think the new hook is the one that we've spoken about here, is that they are very, very, very good at coming up with low carbon solutions. And I think the fact that people have ignored them before because of the complication, which in a way could cost money, was an excuse to let people off the hook. I think there is no excuse now for not coming up with solutions which actually save carbon. And if your client is saying, I want to save carbon, and actually David spoke about the A14, I'm seeing an awful lot of contractors under very heavy contractual pressure to save carbon, as in they will be very heavily penalized or incentivized to make sure that they do it. And if a designer is not capable of designing the low carbon solution, then I think they will lose work very quickly, and therefore they will not do things. So I think actually carbon is a really good hook. What we do need though is to make sure that we get into publications, ICE proceedings, the main version, not the less considered ones, the iStruct journal and other places, some very, very good case histories that show some of the things that David showed, and show people that it is the low carbon solution in many, many cases. So I would advocate that very strongly.
Yes, thank you very much for that. And I think you touch a very good point here, is that I think also it's our fault in our industry. We try to make this much more complex than it is in reality. So people, they don't, they think it's like a very complex area of engineering to start to work on that. But the reality is not that. So it's a way of how we send a message that is an easy way to do it, but also it's a very good way to do it. So yes, I think that is a very good point. Thank you. Well, I think we are almost at the end of this panel discussion. We were not sure how this will work because, as I said at the beginning, it's our first panel discussion online, but hopefully you all enjoyed and at least got a message to get to you and learn a little bit today. So that really, thank you very much for all to come here. Yuli, you want to say something?
No, I thought I was clapping. But it came up as a raising hand. Sorry, because I just agree. I think this is fantastic. That's the first panel discussion. I think it's, for judging also from the comments in the chat, it's been very engaging and people have so much to say, but we just have to start talking to other people. And yeah, so that's all. It was an attempt to clap.
Thank you. And just before we finished, I just want to remind for the people that is mainly in the UK, or anyone that wants to come, please, we have the 6th IGS UK Symposium that this time is in person. This was in 2020 and we had to postpone it to now. It's on the 28th of June. And it's about containment engineering. And we have some amazing speakers. Some of them are here today, but also we have the keynote speakers like George Kerner. He's going to come to do a very nice presentation. And also the Professor Jemina Dimidio, that she has a lot of experience on the area of GCLs. And this will be, again, a workshop session with other speakers. So there is more information in the IGS UK website, but if you are interested, yes, please let me know. And I will stop now and I will say thank you very much to all our panelists. You were great today. Thank you for accepting this invitation. I know you probably you were thinking this is a kind of a trial, but I hope you also enjoy, and thank you very much for all our attendees. It was really nice to have you, and I think this having the cameras also, it helps to try to be in the same place, but also we are in different areas in the world, so thank you very much.
Bye everybody.
Bye-bye.
Okay, bye, thank you.
Thanks everyone, bye.
Bye.
Bye-bye.